Hello, statistics student. This video is for 12.2 and 4, scatter plot and correlation. So our main goal is if we have some match pair data, we will be able to determine if there is correlation. And by going through this process of graphing a scatter plot and also do a hypothesis test or a critical value comparison. So this is another example. So we are suspecting that maybe there is a correlation between shoe size and math scores, which is rather unlikely, but the data seems to point to this direction because when you have low shoe size, it seems to have low math scores. When we have high shoe size, it seems to have. So we're going to do a analysis. So first is always scatter plot. I have entered the data. So if I clear this, I have to enter the child shoe size and math score here in here. You want to do a scatter plot first by doing data scatter plot. Select X and Y, child's shoe size and also math score. And then you can do the label, you can do the title, but most important is to take off the regression line. We don't need that. So this is our scatter plot. The one thing that I want to add that is not on the notes is I want to write down the scale. So the x-axis is child shoe size because that's what I pick, right? And the y-axis is math score. So I go from 8 to 11, and this is 65 to 95. So I'm going to add that. And also just copy the general pattern, right? So this is what I have copied down. So I would write, actually, if you're doing it in your worksheet, you should write down is the shoe size and it's the math score. Oh, I've forgotten the number. I remember it was like 65, is it? 95? So you should, and then, from 8 to 11. So this would be from 8, 9, 10, 11. So label the axis and also scale it. And then you can describe it. You can see that the scatter plot does not show a nonlinear pattern, and actually it shows a upward pattern, right? Now the next thing is to determine if the linear correlation actually is significant. So we use alpha equal to 0.05. So I will go through this one more time. So it's actually always that one. After we do it, we graph the scatter plot. We do analysis, correlation and regression, child shoe size, and math score. Write out significant, which is 0.05. Then I'll write down the three numbers. Under correlation result, 0.876 is R. Critical R is plus or minus 0.811. And p-value is 0.0222. 0.0222 over here. It's a two-tail. So copy these three numbers down. You can also look at the scatter plot again to confirm that yes, it's positive. It's actually quite close. So now let's go back to our output. So our x78, 876 plus or minus 811.02222. So now, how do I know if there's linear correlation? So the easiest way is to check p-value. P-value of rho equal to 0. Our x0 is rho equal to 0. Alternative hypothesis is rho not equal to 0, right? So 0.0222 is less than 0.05. We reject 0. Reject 0, conclude linear correlation. If you use critical value method, then you would look at 0.876. In the positive side, our threshold is 0.811. So 0.87 is here. So past the threshold, close to 1. So it is also linear correlation. So both methods point to the fact that the matched pairs are linearly related. You only need to do one. So the other properties of R is R does not change if X and Y switches. And if you switch X and Y, you would have the same value. So whether they're correlated or not does not the order of X and Y does not matter. And also if you use a different unit, maybe instead of inches, you use cm, or you multiply by 10 times, the correlation also doesn't change. Okay, so that is the study of correlation.